Dear students, welcome to my channel Vikram Sindhu CSE. In this video, I'm going to explain about simplex method. Okay, so my name is Mr. Vikram Sindhu S. I studied BE at SSC Mysuru and MTech at NIE Mysuru, and I am currently working as an assistant professor at Sampurna Institute of Technology and Research. Let us see how this simplex method problem. So first of all, this is a maximization problem. So z is equal to 3x1 plus 2x2. So this is the objective function. So this objective function will be having certain constraints. So that is x1 plus x2 less than or equal to 4. Okay. So this is the first constraint, and x1 minus x2 less than or equal to 2. This is the second constraint. So these two constraints are having inequality. So these inequalities should be converted into equalities. Okay. So when we convert this inequality to equality, we will be obtaining the standard form of this problem. So there are two constraints, both are less than or equal to. So if the constraint is less than or equal to, we have to add a slack variable. If the constraint is greater than or equal to, we have to subtract a surplus variable. So constraint is less than or equal to, so let us add the slack variable for both the constraints. So and thereby we will be converting this into standard form, and also we'll be converting this inequality to the equality. So standard form looks like this: maximization problem, objective function. So in the objective function, what are the changes I have done? So I have added s1 and s2 slack variables with a 0 coefficient. Okay, so in the objective function, you have to add s1 and s2 with a 0 coefficient. Okay, so and then first constraint x1 plus x2 plus 1 into s1. So you are adding the first slack variable in the first constraint. So this inequality has changed to equality over here is equal to 4, and x1 minus x2 plus 1 into s2 is equal to 2. Okay, so you have added the second slack variable over here. Okay, and x1 and x2 should be greater than or equal to 0. So just we'll go to the table next. So just observe the coefficient values. This is called as an objective function. This is the first constraint and this is the second constraint. So first constraint, you have to add a slack variable, first slack variable, that is s1. So second constraint, you have to add a second slack variable, that is s2. Okay, so because the inequality is less than or equal to, if it is greater than or equal to, what you have to do, you have to subtract the surplus variable. Okay, so you have added two slack variables. So in this case, the coefficient of x1 in the objective function is 3, coefficient of x2 in the objective function is 2, coefficient of s1 in the objective function is 0, coefficient of s2 in the objective function is 0. So coefficient of x1 in the first constraint is 1, x2 1, s1 1, s2 0. And the coefficient of x1 in the second constraint is 1, x2 minus 1, and s1 0 and s2 1. Okay, so let us go to the table to solve the problem. So here you see this is the basic variable. BV means basic variable. Whatever is there in this column is called as a basis. Okay, so this CB is nothing but the coefficient of these variables in the objective function. So what is the coefficient of s1 in the objective function? It is 0. So what is the coefficient of s2 in the objective function? It is 0. Okay, so then after that, RHS is the RHS of the constraint. First constraint RHS is 4, second constraint RHS is 2. So and this CJ column is nothing but coefficient of these variables in the objective function. So coefficient of x1 in the objective function is 3, coefficient of x2 in the objective function is 2, coefficient of s1 and s2 in the objective function are 0. Now I have told you what is this. Initially in the basis you have to add the slack variables, both the slack variables you have to add. In the CB column you have to put coefficient of s1 and s2 in the objective function. So this is the RHS of the constraints. So these are the coefficient of these variables in the first constraint. Coefficient of x1 in the first constraint is 1, coefficient of x2 in the first constraint is 1, coefficient of s1 in the first constraint is 1, coefficient of s2 in the first constraint is 0. Coefficient of x1 in the second constraint is 1, coefficient of x2 in the second constraint is minus 1, coefficient of s1 in the second constraint is 0, coefficient of s2 in the second constraint is 1. So we have written the row. So min ratio we'll see how you have to compute a mean ratio. So next process is you have to compute the delta. All the delta values you have to compute: delta 1, delta 2, delta 3, delta 4. So for that you have to use this formula. So that is delta I is equal to CB into Xi minus Cj. Cj means this one. So for delta 1, what you have to do, you have to multiply this with this and subtract the result with this. So let us do that. 0 into 1 plus 0 into 1 minus 3. So it is minus 3. Next, for delta 2, 0 into 1 plus 0 into minus 1 minus 2. It is minus 2. For delta 3, 0 into 1 plus 0 into 0 minus 0. It is 0. Next, for delta 4, 0 into 0 plus 0 into 1 minus 0. It is 0. Okay. So what you can observe here, all these delta values are same as the negatives of these values, because initial stage this CB column will be 0. So that is why, so this delta values will be same as negatives of these values. So in the first step for computing the delta, you can take the negative values of these. Okay, so directly you can take the negative values of this, no need to apply the formula. From second table onwards you have to apply the formula. So now we have got this delta values. Next, let us see what to do. So among these delta values, which is the minimum? Delta 1 is equal to minus 3 is a minimum. So, and another thing you have to observe here, whether all delta I is greater than or equal to 0 or not. No, it is not greater than or equal to 0. You have some negative values here in the lights of minus 3 and minus 2. So you have to continue the problem. If any of the delta value is negative, so you have to continue the problem, and you have to continue until all the delta I are greater than or equal to 0. Okay, so now delta 1 is equal to minus 3 is a minimum. So whatever I have written in the red color here is called as the pivotal column. Okay, so next you have to find the pivotal row. How to do that? Look at the RHS here. RHS, that is 4 divided by corresponding element in the pivotal column, that is 1. 4 divided by 1 is equal to 4. Next, 2 divided by corresponding element in the pivotal column, that is 2 divided by 1 is equal to 2. So in between this 4 and 2, which is minimum? 2 is the minimum, so this is a pivotal row. Whichever I have written in the yellow is called as a pivotal row. The intersection of pivotal row and the pivotal column, this one is called as a pivot element or pivotal element. So next what you have to do is, this pivotal element should be unity. That means you have to make this pivotal element as 1. Already it is 1, so no need to do anything for this case. So if it is not 1, you have to make it as 1. And next what you have to do is, you have to do the row operation for this R2 and R1. So why you have to do the row operation for R2 and R1? So you have to make this as 1, and remaining elements in this column you have to make 0. That means you have to make this as 1. Already it is 1, no need to do anything for this, and this you have to make it as 0. And then obviously if you apply the formula, this will be 0. Okay, so no need to, some authors will apply the formula for this delta also. So no need to do that. Once this becomes 1 and this becomes 0, and when you apply this formula, obviously this also will become 0. Okay, so no need to do the formula like this, apply the formula like this. So R2, what you have to do, anyhow all the values will remain same, because after doing the row operation all these values will remain same, because already it is 1. Okay, so let us, what we have to do, suppose say here 5 is there. So if you want to make this 5 as 1, what you have to do, you have to divide 5 by 5. So this becomes 1. So already it is 1, so divide 1 by 1, so this becomes 1. So all these elements divided by 1. So R5 is equal to R2 divided by 1. So this is R5 is updated value of R2. Okay, so after this you have to do the row operation for R1. Okay, while doing the row operation for R1, you have to use a pivotal row, that means R2. So R2, when you have to use this pivotal row, don't use this R2 values, use this R5 which is updated. Anyhow in this case both are same, but in some other cases, suppose if this value is not 1, these R2 and R5 will be different. Okay, so now you have to use the updated value of R2, that is R5. Okay, so now you have to do the row operation for R4, R1. So for what you are doing the row operation, to make this as 0, to make this value as 0, you are doing the row operation. Okay, so to make this as 0, what you have to do is, see here 1 is there, here 1 is there. Okay, so what how we can make this as 0? 1 minus 1 is equal to 0. Okay, using that formula we can do the things. So R4 is equal to R1 minus R5. So R1 minus R5, this will get you this value 0. Okay, to make this 0, I'm doing the row operation. Okay, so R4 is equal to R1 minus R5. So 4 minus 2, 2, 1 minus 1, 0, 1 minus minus 1, 2, 1 minus 0, 1, 0 minus 1 minus 1. Okay, so this is the formula. As you see this, to do these row operations, I have used this formula. So while using this formula, what you have to consider is, you are doing the row operation for R1. So in the RHS, first element should be R1. Okay, and then there should be pivotal element in this formula. Okay, in this equation there should be pivotal element. What is a pivotal element? R2. What is the updated value of R2? R5. So R5 must be included in the in this equation or in this formula. Okay, so two things you have to consider. One is you are doing the row operation for R1. So RHS of the RHS, first element of the RHS should be R1, and there should be pivotal element. So pivotal element in this case is R2. What is the updated value of R2? R5. So this is there. Okay, so R4 is updated value of R1. So now you have done the row operation. After that you have to compute the delta. So let us compute the delta. So that means this value into this value minus this value is equal to this. Okay, so obviously, as I told you, once you make this as 1 and this as 0, obviously this will be 0. Once you make this as 1 and this as 0, this will be 0 obviously when you apply the formula. So let us see, 0 into 0 plus 3 into 1 minus 3. What is the value? 0. Next, 0 into 2 plus 3 into minus 1 minus 2 minus 5. 0 into 1 plus 3 into 0 minus 0, 0. 0 into minus 1, 3 into 1 minus 0 is equal to 3. Okay, so all the deltas you have got. Look at the delta values. Anywhere you got negative value? Yes, you have negative value. So still we have not attained the optimal solution, so we have to continue. Okay, so before that, one more thing I have to tell you, that this is a pivotal column. So this x1 is called as an entering variable. So this is a pivotal row. So this s2 corresponding to the pivotal row is called as a leaving variable. So x1 is an entering variable, so s2 is a leaving variable. So you have to leave s2 from the basis. So you have to leave s2 from the basis and you have to add x1. So I have done that. Okay, and after that, here what is this? This is the coefficient of x1 in the objective function. So this should be changed to 3 because coefficient of x1 in the objective function is 3. So you have to write 3 here. So earlier coefficient of s2 is 0, so you have written 0. Now you have added x1. x1 is here, no s2 here. So x1 coefficient in the objective function, that value you have to write here. It is 3, so you have to write 3. Okay, so like this you had completed the second step. So now what you have to do next is, in the second step you have to find the pivotal column and pivotal row. Okay, so while doing so, what you have to do is, whichever among delta 1 to delta 4, delta 1, delta 2, delta 3, delta 4, which is minimum, delta 2 is a minimum. So this column is called as a pivotal column, and RHS divided by 2, 2 divided by 2, 1. 2 divided by minus 1 is equal to is negative value. So if you get negative value and infinity in the mean ratio column, you have to ignore that. If you get negative value or infinity, you have to ignore. So there is only one value. So this is a minimum. So this row is a pivotal row. Okay, so then after that, corresponding element in the intersection of pivotal row and pivotal column. This value, this 2 is a pivotal element. So we have to make this as 1. So you had to do the row operation for R4. So what you have to do, what you can do, divide this R4 by 2. That is what I have done. Divide R4 by 2. So this becomes 1. My aim is to make this as 1 and this as 0. That is why I am doing the row operation. Okay. So 2 by 2 is 1. 0 by 2 is 0. 2 by 2 is 1. And 1 by 2 is 1 by 2, minus 1 by 2 is minus 1 by 2. So updated value of R4 is in R7. R7 is equal to R4 by 2. Okay. So what we have done, so we have done the row operation for R4. Next we have to do the row operation for R5. What we have to do, I have to make this minus 1 as 0. So look at the pivotal row. You should not see this because updated value of R4 is R7. You have to see this. Okay. So here 1 is there. Here minus 1 is there. How to make this as 0? Add these two. So you will get 0 here. Okay. So R8 is equal to R5 minus R5 plus R7. Okay. So here you have to observe here. First element in the RHS is R5. So we are doing the row operation for R5. Okay. And then pivotal element should be included in this. So pivotal element is R4. Updated value of R4 is R7. So pivotal row also should be included in this. Okay. So R8 is equal to R5 plus R7. Okay. So this is equal to R5 plus R7. Okay. So let us see 2 plus 1 3, 1 plus 0 1, minus 1 plus 1 0. So and 0 plus half half, 1 plus minus half is half. Okay. So next after that, what is the thing is, so this is 1, this is 0. That is what I wanted to do. Let us compute the deltas. So 2 into 0 plus 3 into 1 minus 3 is equal to 0, and 2 into 1 plus 3 into 0 minus 2 is equal to 0, and 2 into half plus 3 into half minus 0 is equal to 5 by 2, 2 into minus half and 3 into half minus 0 is equal to 1 by 2. So and another thing is this column, whatever the variable is there, x2. So this is the entering variable. So corresponding element to the pivotal row S1 is a leaving variable. So you have to remove S1 from the basis and you have to add x2 to the basis. Once you add x2, what is the coefficient of x2 in the objective function? It is 2. That value you have to write here. And then you have computed the deltas. So all the delta are greater than or equal to 0. So we have attained the optimal solution. Okay. So now you have to stop the process. And in the basis, what are the variables? X1 and x2. So x1 value is in the RHS column, corresponding values in the RHS column you have to consider. So x1 is equal to 3, x2 is equal to 1. So corresponding values in the RHS column you have to take. Okay. So x1 is equal to 3 and x2 is equal to 1. So what you have done? You have obtained the value of x1 and x2. Suppose say in the basis x2 is not there or x1 is not there. So if it is not there in the basis, then its value will be 0. Okay. If it is there in the basis, whatever the corresponding value in the RHS, that you have to consider. Okay. So we got the value of x2 and x1. It is 1 and 3. So x1 is equal to 3, x2 is equal to 1, and max z is equal to 3x1 plus 2x2. Max z is equal to 3 into 3 plus 2 into 1 is equal to 11. The answer is 11. Okay. So in this video I have discussed one problem. So subsequent problems I'll be discussing in the subsequent videos. Okay. So I will be discussing all cases whichever you encounter in the examination. Maximization problems, different variations, and minimization problem, different variation. All the problems I'm going to discuss in the subsequent videos. Right now this is the first video of the simplex method. Okay. So please keep watching my channel Vikram Sindhu CSE. Okay. So next, me and Dr. Mohammad Rafi have written a book on operating system. Please make use of this. This is for the syllabus 18 CS 43, 4th semester CS students, and 17 CS 64, 6th semester CS students, and 15 CS 64. For all the three subjects, same syllabus. So make use of these VTU students. Okay, operating system book for the 6th semester and 4th semester students. It is available in the Amazon and Flipkart online, all the online ways of buying the book. Okay, so it is not available in the bookstore, it is available in online marketing only. Okay, so thank you for watching. My channel name is Vikram Sindhu CSE. Thank you.